Hey team, so this is a series of 3 lessons on linear approximation is what we're working on now. And you can take a second to read this, you can pause it to read the text. We're not going to solve this whole problem just yet, but we're going to use this problem to talk about why we're learning this and where we're going with it. So pause and read the text here. Okay, so hopefully you've read it. What I've done now is I have sketched a graph of all the values in the table here. And this is just a rough sketch so we know what we're talking about. So this would be like t equals 0, t equals 3, t equals 5, and t equals 8. And we know from the text that this is the position of an object moving in a straight line. And notice what we're trying to do here. We're trying to use a linear approximation, so I'll talk about what that means here in a second, when t equals 3 to estimate the position of the object at time t equals 3.2. Okay, so if my second value is t equals 3, t equals 3.2 would be just a little bit past that, right? Okay, and notice we can kind of eyeball it just by having drawn the graph. We have a pretty decent guess about where this is, right? So we're gonna develop a formal method of figuring out exactly like the best estimate for this point, right? So let's put this into context. Maybe this is the position of your car as you're driving along a street, right? And maybe we've only measured where the car is at certain points, and we want to make a best guess about where your car was in between, right? So if I knew where you were at t equals 3, and I knew where you were at t equals, what was the next one, 5, but I want to know where you are in the middle. Well, one of the ways I could make an estimate, I could guess, is based on the speed you were traveling at this point. And notice that's given to us, right? So the velocity of the object is 4 feet per second when t equals 3. Okay. So we know we're going 4 feet per second at this particular point. That gives us some information about where we might end up just a little bit later, right? So what we're going to do, and I'm going to zoom in so I can draw this a little bit clearer. What we're going to do is we're going to use that velocity. So remember, that's just the derivative in this case. We're going to use that velocity to draw a tangent line, right? So my velocity is 4, my tangent line should be positive and like pretty steep, right? So let's say that this line is my tangent line. So this would be tangent to s at t equals 3. Okay. We don't know what the function s actually is, but we can use this tangent line to make a best guess about what the value is at this point, right? Because this tangent line represents how the function's changing a little bit before that point. Okay. And notice our estimate is probably going to be a little bit off, right? Because it's an estimate. That's what we're doing. We're approximating. So in a later lesson, we're going to develop a way of figuring out whether the estimate is an over or an underestimate based on the properties of the derivative. We're going to come back to problems like these in a few lessons. We're going to start with something a little bit more basic though. Okay, so here's an example of a very basic linear approximation problem. So notice f is a differentiable function, and we know this point on f. We don't know what f is. So f of x is an unknown for us. We don't know what it is. But we do know how f is changing. Okay. So we have this derivative, and we have a point on f. We're going to use this derivative to estimate where another point on f is, right? So I can't plug this into f because I don't know what it is. But I can use a tangent line to the graph of f at x equals -4 to estimate. Okay. So the first thing we need is we need to find the equation of the tangent line. Okay. Which means I need to plug in -4 into my slope, right? Or into my derivative to get the slope, which is -4 plus 5 gives me a slope of 9. Okay, so the slope of my tangent line is 9. And notice I use the x that it gives me, not the point at which I'm trying to estimate, right? Okay, so we have our tangent line, and I'm going to use point slope form, so y minus y1. y1 is up here, right? So y minus negative 7 becomes y plus 7 equals 9 times x minus a negative 4 becomes x plus 4. Okay, so this is my tangent line. So this is the equation of the tangent line. My estimate now is going to be what I get when I plug in my x. And this is now my new x, right? So y plus 7 equals 9. And then my new x is negative 4.1 plus 4. Okay. So again, this is where I'm estimating. And then I'm just going to simplify. And the easiest way to do this is actually to isolate y, because that's what we're trying to find here. So I'm going to subtract 7 on both sides first. And these guys combine to 0.1, negative 0.1, right? And then minus 7 is what I get. That simplifies to negative 0.9 minus 7, which gives me negative 7.9. Okay? So that means that based on this approximation, so f of negative 4.1, we could say is about, I'm going to use my squiggly equal sign to indicate that I'm guessing, I'm estimating, negative 7.9. Okay. So pause here, make sure you understand all of my steps here. And if you're unclear how I got something, go back and rewatch that part of the video. I'm going to draw a sketch here of what this looks like at the end, and we'll close out. So here's a picture of what we just did. So my dotted line is f of x. We don't know what f of x is why I made it dotted, right? We're just kind of guessing. My solid line is the tangent line that we just found, right? And what we are doing is we're finding a point at that tangent line to make a guess about what f of x is at that point. So this is our guess. That would be our result here, negative 4.1, comma negative 7.9. Okay, so the tangent line kind of represents a trend in this case, and we're assuming that that point follows the trend. Okay, a couple things to note. Okay, so make sure when you're finding the equation of the tangent line, make sure you use the given x for your slope. Also, sometimes this derivative will just be given to you, so you don't have to do any work sometimes. So sometimes it'll just say f of negative 4 equals 9 instead of making you calculate it. And then make sure when you're plugging in your x, you're using that value that you're approximating. Okay, so we use the given x first at x equals negative 4, tells you where it wants your approximation, and then we use this x second because that's the point we're estimating.